In this next part, we're going to go into the details of what it takes to configure a Spring Boot application to send or dispatch events to Kafka. We'll start with the application property file. Here we can see that we're using the Spring Kafka integration to define things like the client ID, the key serializer, and the value deserializer. Notice here that this doesn't have a Spring Kafka. This is because it's manually defined. So in our case, we're adding to the configuration that we're only going to be dispatching events to a topic called myTopic. The client ID is just what's attached to the event metadata in regards to what specific application produced it, for which we're just using the Spring application name. In terms of the Kafka integration in the dependencies, we're specifically using Kafka streams for streaming data out of Kafka, and then otherwise Spring Kafka for other interactions like sending data to it. Considering that Kafka is really a name-value pair type store, it's meant to store anything, which we typically do with JSON. In this case, I've created a Java class which contains an ID and then 3 fields, A, B, and C, Alpha, Bravo, Charlie, used for representing the data. The intention here is that the ID is going to represent the key for the Kafka event, and then otherwise we're just going to convert this entire thing to JSON and store that as the actual value. When it comes to putting data in Kafka, what we're going to use here is something known as a producer. In this case, I just created a Spring component, and I'm auto-wiring in what is known as the Kafka template. The way this is working is that we're using the Kafka template to send a specific payload, in this case my payload, into a topic, keying it with the given ID. Note here that the purpose of the ID in Kafka has to do with the partitioning strategy. So it's important to understand that when producing data into Kafka, awareness of how the topic of partitions work. Specifically, that you can have a topic that is then broken into multiple partitions. By default, when I dispatch an event to a topic like this, Kafka is going to automatically take that ID and use it as a round-robin type hashing algorithm, so that if I have 10 topics, it's going to selectively, based on that key, decide which partition to put my event into. This means that if I keep having the same ID over and over again, it's guaranteed it's always going to go into the same partition. The reason this behavior is in place is because in some cases you may want to use a custom partitioning strategy, where for example you may want to put users 1 through 26 in partition 1, 27 through 50 in partition 2, and so on. Also note that we're converting this to pure JSON when storing it in the topic. Now we're going to walk through what it takes to configure Spring Boot to be able to stream events from Kafka. In this case, we'll start with the Maven POM. We are using the Apache Kafka Streams library along with the general Spring Kafka integration. In terms of the property file, the most important parts here are with the topic name, which again is not a part of the Spring Kafka configuration. We're manually defining it inside of our property file, but we're then going to auto-wire it into a property. Starting with the first part of the configuration is what's known as the auto reset. So the purpose of this property is to tell the application's Kafka consumer how to behave when it starts up for the first time. What I've done is I've set it up to latest. That means if there are a million events in the Kafka topic when I connect to read it as a consumer for the first time, I'm just going to start from current. I'm not going to have to read in all those events prior. Otherwise, there's another option you can use here if you want to read from the beginning of time. This is an important consideration because, for example, your application may not be able to process a million events in a reasonable amount of time. The next property has to do with the consumer group ID, which we're directly mapping to the Spring application name. This has to do with the functioning of a consumer group. Consider that a consumer group, when it attaches to a topic, that consumer group is going to share all of the partition consumers across everything else sharing that same group ID. That means if I have 2 application instances both sharing the same group ID for a consumer, and there are 10 partitions, it's very likely one will get 5 and the other will get 5. If there's only one application, that one application instance will have all those 10 instances. This is important because it's how you distribute load and do parallel processing across a topic using those partitions. To handle streaming events from a topic, I've set up a general Spring service called SomeEventListener, where I'm auto-wiring in the topic name, I'm also keeping track of the group ID. Note though that if you're dealing with manual offset acknowledgement, you will need the group ID to be able to tell it where the consumer is in the stream. Otherwise, the primary function of this is using the Kafka listener annotation, telling it what topics to listen to, in this case the one topic, and then associating it with that group ID. What's happening here is that whenever an event is put onto the topic, it's going to invoke this method where I'm getting some generic type of consumer record, which is just a key and a payload. And what I'm doing here is I'm pulling out the raw string from that actual event payload, and I'm mapping it back to my payload class, which is just an ID in the ABC fields. Then, in order to demonstrate this, other than just logging it to the console, I'm maintaining a list of payloads that have been received since the application's been up and running.